Connecting a 100 amp panel to an existing meter is possible, contingent upon several factors. Firstly, the meter socket capacity must be assessed. Check the meter socket to see if it's rated for a higher amperage, such as 200 amps. This rating indicates its ability to support a high capacity panel. Secondly, the wiring size needs evaluation. The existing wiring from the meter socket to the panel must be appropriately sized for 100 amps. Typically, this requirement translates to using number 4 AWG copper wire. Thirdly, the panel load is a crucial consideration. The combined load on the 100 amp panel, encompassing the oil burner motor, must not exceed the total capacity of the meter service, which in this scenario is 200 amps. To verify whether connecting a 100 amp panel to the existing meter is feasible, follow a structured approach. 1. Inspect the meter socket. Open the meter socket and examine the rating plate located on the inside. This plate should specify the maximum amperage capacity of the socket. 2. Check the wiring size. Measure the diameter of the existing wires that feed the panel. Utilize the AWG wire size chart to determine if the wires are suitable for carrying 100 amps. 3. Calculate the panel load. Add up the amperage ratings of all the circuits and devices connected to the new 100 amp panel, including the oil burner motor. Ensure that the total load does not exceed 200 amps. Consider the additional aspects. Upgrading the house panel to 100 amps may necessitate additional labor and materials, which includes new circuit breakers and wire runs. Address the underlying cause of the 40 amp main tripping and the repeated oil burner motor failures before undertaking any modifications. Consult with a qualified electrician to guarantee that the upgrade is executed safely and in compliance with all applicable codes. Focusing on the electrical system, let's examine the components and their functions in more detail. The meter socket serves as the entry point for electrical power into the building. It houses the electric meter, which measures the amount of electrical energy consumed. The meter socket must be adequately rated to handle the amperage demands of the electrical system. The wiring that connects the meter socket to the panel is responsible for carrying the electrical current. The size of the wire is crucial, as undersized wires can overheat and pose a fire hazard. The AUG American wire gauge standard is used to specify wire sizes, with smaller numbers indicating larger wire diameters and higher current carrying capacity. The electrical panel, also known as a breaker box or load center, is the distribution point for electricity within the building. It contains circuit breakers that protect individual circuits from overloads and short circuits. Each circuit breaker is rated for a specific amperage, and the total load in the panel must not exceed its capacity. The oil burner motor is an electrical device that consumes a significant amount of power. Its amperage rating must be considered when calculating the total load on the electrical panel. Overloading an electrical circuit can cause the circuit breaker to trip, interrupting the flow of electricity. In severe cases, overloading can lead to overheating, insulation damage, and electrical fires. Low voltage can also damage electrical equipment, including motors. The 3 horsepower motor operating on 230 volts requires a dedicated 30 amp circuit. Understanding how voltage drop affects motors is essential. Voltage drop is the reduction in voltage that occurs along an electrical conductor due to the impedance of the wire and the current flowing through it. Excessive voltage drop can cause motors to overheat, lose efficiency, and even fail prematurely. The National Electrical Code, or NEC, provides guidelines for safe electrical installations. It specifies minimum wire sizes, of recurrent protection requirements, and other safety measures to prevent electrical hazard. When upgrading an electrical panel, it is crucial to comply with the NEC and all local electrical codes. A qualified electrician has the knowledge and experience to perform electrical work safely and correctly. They can assess the existing electrical system, determine the appropriate size of the new panel, and ensure that all wiring and connections are properly installed. The electrician will also verify that the new installation complies with all applicable codes and regulations. A load calculation is a critical step in determining the appropriate size of an electrical panel. It involves adding up the amperage ratings of all the circuits and devices that will be connected to the panel. The load calculation must account for both continuous loads, which operate for 3 hours or more, and non-continuous loads. The NEC provides specific guidelines for calculating electrical loads. In addition to the general lighting and appliance loads, the load calculation must also include the amperage requirements of any large appliances or equipment, such as the oil burner motor. If the load calculation indicates that the existing panel is undersized, it must be upgraded to a larger capacity panel. Upgrading the panel involves replacing the existing panel with a new one that has a higher amperage rating. The new panel must be properly grounded and bonded to ensure electrical safety. All wiring connections must be made according to the NEC and local electrical codes. The electrician will also inspect the existing wiring to ensure that it is in good condition and properly sized for the new panel. If the existing wiring is undersized, it must be replaced with larger gauge wire. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, causing the circuit breaker to trip and to energize the circuit. Bonding connects all metal parts of the electrical system together, creating a low impedance path for fault current. Proper grounding and bonding can prevent electrical shock and reduce the risk of electrical fires. Before starting any electrical work, it is crucial to disconnect the power supply. This can be done by turning off the main circuit breaker in the electrical panel. Always verify that the power is off by using a voltage tester. Never work on live electrical circuits, as this can result in serious injury or death. When working with electrical wiring, always use insulated tools. Wear appropriate personal protective equipment such as safety glasses and gloves. Be aware of your surroundings and avoid contact with grounded surfaces. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Always follow the manufacturer's instructions when installing electrical equipment. Use only approved electrical components and materials. Do not attempt to modify or repair electrical equipment unless you are qualified to do so. Regularly inspect your electrical system for any signs of damage or deterioration. Look for frayed wiring, cracked insulation, and loose connections. If you notice any problems, have them repaired immediately by a qualified electrician. By following these safety precautions, you can minimize the risk of electrical hazards and ensure the safe operation of your electrical system. The specific requirements for electrical installations can vary depending on the local electrical codes. It is important to consult with your local building department or a qualified electrician to determine the applicable codes in your area. The NEC is updated every 3 years, so it is important to stay current with the latest edition. The NEC provides detailed information on all aspects of electrical installations, including wiring methods, overcurrent protection, grounding, and bonding. By following the NEC, you can ensure that your electrical system is safe and reliable. In summary, determining if a 100 amp panel can be connected to an existing meter involves assessing the meter socket capacity, wiring size, and panel load. It is crucial to comply with the NEC and local electrical codes and to consult with a qualified electrician to ensure safe and proper installation. Always prioritize electrical safety and take precautions to prevent electrical hazards. The importance of accurately calculating the load requirements for the new oil burner cannot be overstated. Motors, especially during startup, draw significantly more current than their running amperage. This inrush current, also known as locked rotor amperage, can be several times the motor's rated current. The circuit breaker and wiring must be sized to accommodate this inrush current to prevent nuisance tripping and ensure reliable operation of the motor. The existing 2-pole 30 amp breaker may have been adequate for the previous heating system, but the new 3 horsepower motor likely has a higher inrush current. This could explain why the 40 amp main breaker is now tripping occasionally. To properly size the circuit breaker and wiring for the oil burner motor, consult the motor's nameplate for its full load amperage and locked rotor amperage. Use the NEC tables to determine the appropriate conductor size and overcurrent protection based on these values. Consider using a time delay fuse or circuit breaker with a high instantaneous trip rating to accommodate the motor's inrush current without tripping unnecessarily. Also, the previously existing old heating system was not requiring the proper 30 amps 230 volts as the new oil burner motor does. The heating contractor was reusing the existing breaker and circuit, which now may cause the low voltage issue due to the wire gauge being inadequate. The fact that the oil burner motor has failed twice in 2 weeks is a significant concern and suggests a potential electrical problem. Low voltage can indeed damage motors by causing them to overheat and draw excessive current. Other potential causes of motor failure include overloads, short circuits, and mechanical problems. Before replacing the motor again, it is essential to thoroughly investigate the cause of the failures and address any underlying electrical issues. Measure the voltage at the motor terminals while it is running to check for voltage drop. If the voltage is significantly below the rated voltage of the motor, investigate the wiring and connections to identify the source of the voltage drop. Ensure that all connections are tight and corrosion-free. If the voltage drop is excessive, consider upgrading the wiring to a larger gauge to reduce the impedance and improve the voltage at the motor terminals. It is also important to check the motor's overload protection. Most motors have built-in overload protection devices that trip the motor offline if it overheats or draws excessive current. Verify that the overload protection device is properly sized and functioning correctly. If the overload protection device is tripping frequently, it may indicate a problem with the motor or the load it is driving. Before upgrading the house panel to 100 amps, it is essential to carefully evaluate the existing electrical system and determine if the upgrade is truly necessary. A 200 amp service should be sufficient to supply a 14-unit apartment building, but if the existing service is overloaded, it could cause problems for all the tenants. Perform a load calculation for the entire building to determine the total electrical demand. Consider the amperage ratings of all the appliances, lighting, and equipment in each apartment, as well as any common area loads. If the load calculation exceeds 80% of the 200 amp service capacity, it may be necessary to upgrade the service to a larger size. Upgrading the service involves replacing the meter socket, service entrance conductors, and main panel with components that are rated for a higher amperage. This is a major electrical project that should only be performed by a qualified electrician. Before making any changes to the electrical system, it is crucial to obtain the necessary permits from the local building department. Electrical work is subject to strict regulations to ensure safety and prevent hazards. Failure to obtain the required permits can result in fines and penalties. Always follow the instructions and guidance of the building department and the qualified electrician to ensure that the electrical work is performed safely and in compliance with all applicable codes. In conclusion, addressing the electrical issues in this 14-unit apartment building requires a systematic approach. Evaluate the existing electrical system, perform load calculations, investigate the cause of the motor failures, and consult with a qualified electrician to determine the best course of action. Electrical safety should be the top priority, and all work should be performed in compliance with the NEC and local electrical codes. With careful planning and execution, the electrical system can be upgraded to meet the demands of the new oil burner and provide reliable power to all the tenants. Remember, a proper electrical system should be properly sized and also installed correctly. The correct electrical panel would allow for proper connection of breakers. This would allow for correct operation of the loads as well. Using incorrect wire gauges or breakers can cause issues. This could cause electrical fires, short circuits, and low voltage conditions. Make sure to contact a licensed electrician to have them handle this task with proper tools and training.